Hi everyone. In this class, we are going to learn about the next important hybridization, that is sp2 hybridization. sp2 hybridization. Hybridization. This is the next topic that we are going to learn. Okay, so in this class we are going to learn about what is called as sp2 hybridization, and I will explain with your own example. Okay. Now, so this type of hybridization you will get by the involvement of the one s orbital plus two p orbitals, Okay. So by that you will get a three equivalent, you get a three equivalent sp2 hybrid orbitals. You will get a three equivalent sp2 hybrid orbitals. Okay, these three equivalent sp2 hybrid orbitals, they have a equal energy. Equal energy. At the same time, they have a equal shapes. They have equal shapes also equally. Okay. So you will get a three equivalent sp2 hybrid orbitals. You will get by the combination of one s orbital and two p orbitals. Okay. So by that we'll get a three sp2 hybrid orbitals. Okay. Now, so in these three sp2 hybrid orbitals, so each sp2 hybrid orbital consist 33.3% S character, and remaining 66.6% P character. Okay. So this each sp2 hybrid orbital will consist of 33.3% S character. It will have a S character, and this is the percentage of P character in this sp2 hybrid orbitals. Okay. Now, so these sp2 hybrid orbitals will orient around the central atom in the degree of 120 degrees. Around the 120 degrees, they will orient around the central atom. Okay. So I'll explain by taking one small example here. Okay. To explain this sp2 hybridization, I am taking the example, that is boron trichloride. I am taking the example of boron trichloride. Its name is boron trichloride. So in this, boron is the central atom, and chlorine, three chlorines are the surrounding atoms. Okay. If you see the electronic configuration of the central atom, boron. So boron atomic number 5, its electronic configuration is like this: 1s2, 2s2, 2p1, 2p1. So the ground state electronic configuration is the ground state electronic configuration. The ground state electronic configuration. Okay. Now, so what I was saying here is the ground state electronic configuration. Okay. Now, if you see that it's excited state, that means, okay, if you see that it's excited state electronic configuration, one of electron from the 2s orbital will move to the 2p orbital. So by that, you will get a 1s2 and 2s1, 2p2, either excited state electronic configuration. Okay. If you see here, there is one half electron in the 2s orbital and there are two half-fill electrons. There are two half-fill electrons in the each 2p orbital. There is one here. So there is a one half electron in the half-fill electron in the 2s orbital, and there is one more half-fill electron in the 2p and 2p orbital. There is a two, these are 2px, the 2py, these are 2pz. Okay. Now, and these are 2s orbital. These are 2s orbital. 2s orbital. Okay. So there is a half-fill electrons in the each p orbital. In each orbital. Okay. Now, so this one 2s orbital and 2px and 2py orbital. So this involved in the hybridization. Okay, already. So this involved in the hybridization. Okay, that means so one 2s orbital, 2s orbital plus 2px orbital plus 2py orbital. So they involve in the hybridization. So by that, we will get a 3 sp2 hybrid orbitals. Okay, so already we know the shapes of these orbitals. Spherical shape is the s orbital. Spherical shape is the s orbital, and remaining px orbital is the dumbbell shape. Okay, in the x direction. Okay, so py also in the dumbbell shape in the y and on the y axis. Okay, so these are the shapes of the s and 2px and 2p orbitals. Okay, so by intermixing that, you will get a 3 sp2 hybrid orbitals. Okay, so these 3 sp2 hybrid orbitals will orient. So here, okay, these 3 will get a 3 equivalent energy with equal shape. Okay, so these 3 sp2 hybrid orbitals will orient around the boron with an angle of 120. With an angle of, they will orient with an angle of 120. So there is a one sp2 orbital. So the one more sp2 orbital. This is one more sp2 orbital. This is one sp2. This is one sp2. Okay. So they will orient in angle of 120 degrees around the central atom boron. Okay. These are the okay. So already we know. So each hybrid orbital will consist of big loop positive sign. Okay. A big loop will form with positive sign, and a small loop will form with a negative sign. Here also. Okay. Big loop will form with a positive sign, and a small loop forms with a negative sign. Okay, like this. So this is the positive sign. Okay. So and they have a half electron. There is one electron on each orbital. Okay. There is one electron here. There is one electron here. Here also there is one half electron here. Here also there is half electron. I will draw with the other. Okay. So there is a half electron in each sp2 hybrid orbital. Okay. There is one half electron. Okay. Next, this is the simple metal one. Okay. So we have surrounding atoms. So if you see the surrounding atoms electronic configuration, so go with the surrounding atom electronic configuration, that is chlorine. Okay. So atomic number 17. Atomic number 17. So it have a neon 3s2, 3p5. Okay. So here only there is one electron required for a octet configuration. Okay. You see here. So in the px, 3px, two pair of electrons, and 2py, there are two pair of electrons there, and in the 2pz, in the 3pz, there is a one half electron. Okay, so it need one more electron. That's why. So chlorine, for getting the one more electron, it make a bond with the boron. Okay, just it will be overlap for making the bond to overlap with the. So what is the shape of this orbital? So there is a 3pz orbital with a dumbbell shape. Okay, is a double edge. Okay, is a 3p Z orbital. So it with one electron. Okay, so just it will overlap with the 2p sp2 orbitals. sp2 orbital. Okay. Now, so they will overlap with the, so here one chlorine with the s3p Z orbital. While overlapping, this half electron will be paired up with opposite spin. Okay, they will be paired up with the opposite spin. Okay. So here one chlorine. Okay. Here one more chlorine overlap with the 3p Z orbital. Okay, and electron will be paired up. Electron will be paired up with the opposite spin. Here one chlorine overlap like this. Okay, here one more chlorine overlap with the, so overlap with the sp2 hybrid orbitals with the 3pz orbital. 3pz. Okay, so pz orbital. Okay, 3pz orbital of chlorine. Okay, either 3pz orbital of the chlorine. Either 3pz orbital of the chlorine. Okay, now, so here, so already we learned. So by the overlapping of hybrid orbitals and atomic orbitals, always will give a sigma bond formation. Okay, here will give one sigma bond formation. sp2 pz overlapping. Here sp2 pz overlapping. Here sp2 pz overlapping. We will get a three sigma bonds, three sigma covalent bonds around the boron will form. The shape will be like this. Okay, boron, it make a three sigma covalent bonds, with chlorine, three chlorines with a bond angle of 120 degrees. Okay, here all are bond pair electrons. Okay, now so with the angle of 120 degrees, they will make a, okay. So the geometry of this molecule is, trigonal planar geometry. It possesses a triangle planar geometry. Okay, now here, so we have to keep in mind, so hybrid orbitals overlaps for making the only sigma bonds. They never forms a pi bonds. Okay, so like this, so we get our molecule boron trichloride with the geometry of trigonal planar with the bond angle of 120 degrees. 120 degrees. Okay, so this is about the sp2 hybridization. Thank you. Have a nice day.